geometric solids, starting out with a square, circle, and triangle, and moving to a cube, sphere, cone, and pyramid. And I like to include this. It's a ribbon. Okay. So the first couple things I want to try to go through are some tools on how to construct these. The cube starts out like this. Starting with this little kind of, you can almost think of it as a Y. And then you need to add so here's another way to think of it. You have a Y, and the top is a diamond. And then the side is a diamond, and this side is a diamond. We want to think of this as having an axis. So in this case, this line here, and then in the center of the form, that's our axis. So here's a line, and then into the center of the form. And let's try and construct some around some different axes. Here's an axis right there. Okay, see how I did that? So I'll do another one. Here's an axis, and I'm going to build my Y right around it. There's that diamond. That's a cool one. Oops, sorry. Just spilled that one. Now this one is a different shape. How come that one is different? Let's talk about it. So when we introduce a three-dimensional shape, the cube, and in math we're used to thinking about a shape. When we think about a shape as cubed, right, it means it's got the dimension of length and width, and that dimension also. It's got It's got that dimension also. So it's got the x, the y, and the z. Okay. And now that we've introduced 3 dimensions, so we've been working with type, with print, and as we thought about shapes, we were trying to make our shapes interesting and beautiful according to a 2-dimensional notion. Right, so this shape becomes beautiful and interesting not because of its 3-dimensionality, although I think that there is 3-dimensionality kind of insinuated by the shape. Okay, but this shape becomes cool based on the dynamics of its 2D representation. But now what we're moving into 3D representation. So when we start thinking in terms of 3D, you see this only has one side. Now 3D is going to have 1, 2, or 3 separate sides. Okay, so we could say a 3D cube in the distance might be represented by this. Say, like, if you're looking straight at a building way in the distance, you could have a little door here, but you know that this building has depth, right? And now if you had a building that was just next to it, but let's say we're viewing this from about this line, okay? And if we have a shape, if we had a building that was right next to it, only shorter, well, it doesn't even have to be shorter. Let's say this is at the end of an alley. Okay, now this building has 2 sides, right? And then we could say if we were going to try to draw like a car in the foreground pulling up to this little building, and we were just going to rough it in, and now this has 3 sides. It has 1, 2, 3 sides. Okay? Notice the reference to this line. This line is called the horizon line. And it tells us how high or low, whether we're viewing an object from above or below. So if we have a cube above it, above the horizon line, say I've got a car jumping over this building and it's right here. So I see the bottom of that, whereas this one is below the horizon line, so I see the top of it. See, this is the bottom, and this is the top. These ones, which go to either side of the horizon line, I don't see the bottom or top, okay? So let's do cube practice. I'm going to draw a set of cubes whose axes is all this way. However, this one is going to be at my eye level. and this will be below eye level, and that direction will go above eye level, okay? So here I'm starting to go below eye level. And I'm going to go further below eye level. Here will be above eye level. And further above eye level. Notice while things are closer to the horizon line, here's my horizon line. Notice while things are closer to the horizon line, we see less of the top and less of the bottom as they get further away from eye level, as we're looking more and more down or up at them. Like see here, we're looking way down at it. So if we imagine a viewer, like here's a viewer, and they're standing right there, and when they look at this cube here, they don't see that much of the top, whereas when they look at this one, they see lots of the top, okay? Okay, so there are a couple of main mistakes that can happen when drawing a cube. The three main mistakes of cube drawing, okay? Okay. Okay, the first mistake of cube drawing is this. And I call this one a party hat. Okay, and what's happening is, it's like this little guy is wearing a party hat. You could circle it and put a little tassel on the top of it. Okay, so what's going on is these two lines need to be repaired, and this is how we'll repair them. So here was the party hat. Okay? And it can happen on either side of the cube. So for instance, if we're looking at a cube like this, and here's the repair. Okay? The second mistake is if I have this part of the cube, and then I go like this. Now, what's going on here is that this line and this line they're not participating in the same axes as this line, right? Now, if the cube we're drawing has a vertical axis, which this one has, if we think of the center of this cube, these two would want to be vertical also. At whatever direction the axis is going, all three of these lines want to participate in it. Okay, so let's call this one a lost axis. And so here's how we fix it. We start out with a cube drawing, making sure not to get a party hat, but then we were in a hurry, and here I'm losing my axes in two separate directions. Okay, and see how this cube looks askew? Find the axes that you're committed to using. You can even make a note of it. And let all of the lines, all of the verticals in this instance, match the axes. Now let's do one that's not vertical. Here's going to be my axes this time. I'll start out with the axes, okay? I'll mess this one up, and I'll mess this one up. It becomes the base of a pyramid. If we allow that to happen, it becomes the base of a pyramid. And so what I need to do is, I need to get this line to be the reference for the rest of these. And usually this one, a lot of times this one will be pretty close to correct. But that fixes it. It makes things look good. Okay, that's the lost axes. Okay, now the third one is this. Try not to get the party hat. We're going to get our axes correct. And here. Again, it looks bad, right? And this time what we've done is we've let this leg and this leg get long. And so this is the correct line. Okay. So I'm sketching a cube, and then I'm going to go through and check for each of these possible mistakes. And generally it will really fix it up. Okay, so let's take a cube here and just say that we were really quick. We're rushing along. We need a cube to occupy about that much shape. And so we get through our sketch phase of the cube. And then what I want to do is go back and say, okay, here's my axes. Let me make sure that these lines conform to that axis. This one is turning out to be a little bit off. Okay, very good. Everything is lining up with the axes. Then let's check for the party hat. I want to see what happens if I lower it just a touch. Seems like okay to lower it just a touch. And now let's see if any of these, if any of these here if this line is ever longer than this line, than the front line, or if this line is longer than the front line, then I'm out. Okay, and so these are the three main mistakes of cube drawing. Let's move on. Next thing that I want to practice with you guys is drawing spheres. To draw a sphere, you really need to start to practice ellipses. When I practice ellipses, I do a middle, and then I do a thin. And then I do a circle. That's the wide. And here's how these work, is that if you have eye level, at eye level, an ellipse, a circle sitting looks like that, sitting on the ground. As it goes below eye level, it starts to do this. And then further below eye level, the diameter, the distance across the middle, grows, where these stay the same. So here, I want to draw one with the even bigger diameter now. And then here will be one with an even bigger diameter. And that starts to give us the idea of this thing going down in space. It works the same going upwards. Notice this line here, this kind of line that we've been working from. The way that this line splits the ellipses in two, you see this is a really important axis right there. It's what it is it goes across the small portion, directly across the small portion of the ellipse, and they call it the minor axis because it's crossing the minor. This would be the major axis crossing this way, okay? So if we project that axis upwards and we project the sidelines upwards, this projection gives us these, and this projection gives us these. So directly above the horizon, just starting to kind of look up at this thing, it'll go about like this. Looking way up into it, and that gives us the tools to start to draw an official cylinder. So we can go like this, just draw an ellipse, cut it in two. See how I've got symmetrical on two sides? Draw another ellipse. Here's the length that the ellipse needs to be. This is the place that it needs to be cut into. And remember, when we drew the cube, we had an axis. Well, this is our axis. And now we can draw one based on an axis. We can say, well, this is the axis that I want to draw it on. Okay, here I'm drawing on this axis. Okay. Any axis you can come up with, you can draw a cylinder on. And the next shape is a lot easier once we've got the cylinder. Let's draw a cone. So ellipse, find the major axes, the minor axes. Here's the center. And there's a cone. We can draw the axes first. Depending on the scale of the diameter, that tells us how much of this of the cone, how much of this side of the cone we'll see. Like, for instance, watch this. If I take the diameter and I make it like this, like almost round as an ellipse, it's not a circle. Okay, so now I'm really looking at that one from way below, and I'm not seeing that much of this side. There's my point of axes. Now look at, what if I make the ellipse really, really skinny? That tells me it's almost in line with where I'm standing. Okay. Cones. So, pyramids. With a pyramid, you start out with a cube, like what would be a cube, but we're not going to make it into a cube. And you put an X through it from corner to corner. And when you put an X through it, that tells you where the center is. And then you connect from the corners to a point. So here's a pyramid we're seeing three sides of. Okay? And this pyramid looks like it's got a little bit of a party hat, doesn't it? Like here, this looks wrong. That's going to be better. Better. Okay? So we'll draw another one. This time I'll have the axes be really different. Here's going to be my center line. Here's my axes. And that's cool. I'm seeing 4 sides of it because it's right at eye level. Here's my axes, this time going there. So this one is like I'm flying over it. Just seeing, looking right down at the top of it. Oh, this one has a party hat too. I'll make it better. Okay, so we've got the cube, the cylinder. Now we need the sphere. To draw the sphere, you start out with a circle. But depending on the direction of the axes, you're going to overlay it with cross contours that really show the dimensionality of it. So let's say the axis is going this way. What you want to do, pass the axes directly through, okay, and then start to build ellipses based on, let me see if I can't help my focus there. Based on that. Okay, so here I'll do this one different. I'll make this one right there. And there I'm just implying it. These lines are called cross contour lines because they cross the contour. that would be the axes there. And the last one we're going to work on in this lesson is going to be the ribbon. And it curls around behind. Here, I'll curl this one around behind too. And the ribbon is a classic and great 3D effect. Like we can take a ribbon and wrap it around our other ones. And this ribbon is really twisting and turning. Okay, those are our geometric solids. More to come. Good luck with those. Practice. Practice is the key to getting really good at these.